Welcome to my class. Today I will discuss motion in two dimensions. Motion in two dimensions. So up to now we discussed motion in one dimension space. So linear motion up to now I discussed with you. So today I am going to discuss motion in two dimensions. Okay. Motion in two dimensions. Motion in two dimensions. Motion in two dimensions. See, motion in two dimensions. See, up to now we discussed motion in one dimension. So that is along x direction. Otherwise along y direction. Otherwise along z direction. So the body is moving along x direction. Otherwise the body is moving along y direction. The body is moving along z direction. Whatever it is. That means the body is moving in one particular direction, in linear direction. So when the motion in two dimensions, that means let it is x axis, this will be y axis. So this is the origin. The body is moving like this. So the body is in motion in a plane, that is xy plane. The body motion is moving in xy plane. The body is moving in xy plane. So then its velocity get two components. Its velocity get two components. Its velocity get two components and acceleration also will get two components. Up to now we discussed the motion along x axis, otherwise along y axis, along z axis. It is linear motion. It is different. So motion in the xy plane. So the velocity, initial velocity has this velocity component along x axis, that is ux, this velocity component along y axis, that is uy. So that is the difference between in one dimension motion and two dimension motion. So what I am saying is simply this is x axis, this is y axis. The velocity direction like this. The velocity component along x axis. Velocity is a vector quantity. Along x axis the component is ux. This is uy. So we can write velocity uxi component uyj component. So like this we can split velocity vector in two components. This magnitude along x axis, this magnitude will be along y axis. So the vector u vector is ux I cap plus uy j cap. Just write it this one. See what I did here. The velocity component I split into two components. I resolute the vector along x axis, along y axis. Along the x axis the component is ux, along y is uy. So this is I resoluted, just you copy it. like that. See, the if the body is motion like this, so the body, it is changing its velocity, so it is getting acceleration. So acceleration also like that. The acceleration vector, acceleration is also vector quantity. So it has along x-axis ax component, along y-axis ay component. So we can write vector a equal to ax I component plus ay j component. So this is vector velocity vector. I can split into two components, along x-axis, along y-axis, like that. Acceleration vector also I split into two components, along x-axis, along y-axis. So along x-axis the unit vector will be I cap, along y-axis the unit vector will be j cap. So here I am denoting, this is cap, I cap, this is called unit vector. Unit vector. See, along x-axis I cap is there, along y-axis j cap is there. Okay. See, I am writing for you. It is new topic, vectors. So just I am simply, if the body is in motion in any plane, for example it is yz plane, so the motion will be like this. The vector, unit vector, the velocity vector, we can write along uy j cap uz k cap, like that we can split it. So what I am discussing here, the motion along x-axis, linear motion bodies already we discussed up to now in last classes. The body is moving along x-axis, the body is moving along vertical y-axis, the body is moving along z-axis. That is linearly moving bodies. But here I am discussing the motion in two dimensions. Two dimensions means it has x-axis and y-axis. Both directions are there. So the body is moving in plane, in xy plane. For example, already taken like this. This is xy plane, x-axis, y-axis. The body is moving like this. The vector is like this. So velocity is a vector. I already explained. Speed is the scalar. Velocity is the vector quantity. So the vector u we can split as like this component. I am explaining one more time. The vector ux along ux component along x-axis plus uy along y-axis. These are the magnitudes. These are the directions. So we can write u vector, the velocity vector ux I cap plus uy j cap. Like that, acceleration also we can write ax component along x-axis, ay component along y-axis. So we can write. So the motion in two dimensions only. So that's why I taken here x and y-axis only. If we take three dimensions, we can extend uz along z-axis. K cap also will be there. So now I am discussing this topic, the vector u we can split into ux I cap plus uy j cap. Acceleration split into two components, ax I cap plus ay j cap. Okay. Based on this, so the kinematic equations, how will it change? That is, if the body is motion in two dimensions, the kinematic equation first, v equal to u plus 8. V equal to u plus 8 already we know. Okay. So the velocity has along x-axis, it is there, along y-axis. Just we change the equations. Along x-axis, vx component ux plus ax into t. Like that, vy velocity along y-axis, initial velocity along y-axis plus acceleration along y-axis into t. So one more equation, s equal to ut plus half at square. Sx ux into t plus ax into t square sy uy into t plus of ay into t square. Next, v square minus u square equal to general formula, this one. In two dimension, along x axis is there, along y axis is there. So along x axis, vx square minus ux square equal to 2ax into t. Vy square minus uy square equal to 2ay into t. Just you copy. This is for linear one dimensions motion. This is for these two for two dimensions. Just copy it, these formulas first. Neatly copy first. So, did you copy? Did you copy it? Is it visible for you? Complete. Okay, nice. So what we discussing here? Motion in two dimensions. Two dimensions mean along x-axis, along y-axis is there. The motion in the plane. The motion will be in the plane. That we can call as two-dimensional motion. Okay. Next. So I am discussing, up to now I discussed in kinematics, freely falling body. Freely falling body. So for this condition u equal to 0, a equal to plus g. One concept. Body projected vertically up. So v final velocity is 0, a equal to minus g. Next, body projected vertically up from a tower. From a tower. This is also, so this is all one more case. So I discussed up to now. These are all one dimension motion almost. Either it is going up, either it is coming down, either it is going and coming down. So these motions we discussed. This is freely falling body, this is vertical up, this is projected from a tower. So this is the tower. I discussed in the last class. The body projected vertical left from the tower. The height is h also we calculated in last class. That is equal to h equal to minus ut plus half gt square. So this is the equation we got it last class. So up to now I discussed these things. So today I am going to discuss in two-dimensional motion, projectile motion. Projectile motion. Motion is projectile motion. Projectile motion. So what is projectile motion? You just write this sentence also. So projectile motion, the motion in a plane. So the body should be moved in plane only. Then we can call it projectile motion. Then it should move with constant acceleration. Constant acceleration. So just you write these 2 points for projectile motion. So in projectile motion, the path of the body. So what happens here in projectile motion? This is x-axis, this will be y-axis. The body moves like this. So initial velocity in this direction. So we projected a body with some initial velocity, then only the body will go like this. Okay. See, on this body, the gravitational acceleration acts downward only. A equal to g. So what happens when we projected with initial velocity u, it has to move like this actually. It has to move like this, but it is not moving like this. What happens? The gravitational force acts on that body. It will change the acceleration, change the direction of the projected body. So like this it will change. Finally it comes to the ground. It starts with initial velocity u and comes to the ground with initial velocity. So what happens here? Generally if we projected initial velocity, it has to move like this, but it won't move like this. It will change the direction, velocity direction, and comes to the ground. The acceleration, constant acceleration will act throughout the journey. So then we can say the projected body is in two-dimensional. Projectile motion is in a plane. So projectile motion nothing but the body moves in a plane. This is xy plane. So path of the body is parabola. Path of the body this is the parabola. Parabolic shape is this one. So the path of the body of projectile motion is the one point, parabolic path. Parabola. Generally we know this is circle. So this shape is parabola. Parabola. Just you write path of the body. Path of the body of projectile. Projectile is parabola. Okay. Right. Then we can call it, if the path of the body of projectile is parabola, then we can call it as projectile motion. Otherwise, if the body is moving in projectile, the path of the body will be parabola. Whatever it is, converse. Okay. Next. See, I am giving here different types of projectile motion. Different types of projectile motion. So just you copy the graphs. This is along x-axis, this is y-axis. Like this. This is u. This is obliquely projected. Oblique projection. Oblique projection. Oblique projection. So it is making theta with the x-axis. The angle it is making angle. The angle we can call as theta. Theta. The angle we can call is. So the initial velocity vector is making angle with along with x-axis, that is theta angle. Okay. Next, second, horizontal projection. So like this, x-axis, y-axis. So what happens here? See, projected horizontally with initial velocity, then the body will move like this. Here it is will move the body. if we project a horizontally with some velocity, if you project a ball, the ball will not go like this straight only, it will fall, it will like this fall, like this. If you projected a body with initial velocity, the body will follow the path like this. This motion is horizontal projectile, horizontal projectile. Okay, right. Just copy it. One more diagram I am giving. X-axis, y-axis. So this is height. So if you project with u velocity, we are projecting initial velocity with u from a height. From a height. So that means the body, the path of the body, the journey travel like this. It will move like initially. It will move like this. It will go up and comes down. I think it is not right like this. So along the velocity vector, then comes down. So this is the path. See, first one is oblique projection. The velocity vector making angle with x-axis. Here the velocity vector is parallel to x-axis. Is parallel to x-axis. Then we can call it the horizontal projectile. We are projecting like this. Okay, so projected like this horizontally. That means this is parallel to x-axis. So that is horizontal projectile body. Here from a height we are obliquely projecting. See, we are projecting a body from a height. From a height, then we are projecting here the velocity vector making angle theta with the horizontal. So that is the difference. So what is the difference here? In C case, is it visible? Yes. So this is the height. From height we are projecting obliquely. Obliquely means making angle theta with the horizontal. So the body will go initially like this, then falls down. Is it? Okay. This motion obliquely projection. So you just write oblique projection from height. Oblique projection from a height. So this third type. Okay. Next, I am rubbing this one. Just today I give these graphs only. Tomorrow I will explain. Right. See one more. D type. This one, downward projection from a height. Downward projection from a height. See, this is x-axis. This will be y-axis. Downward projection from a height. This is a height. See, we are projecting downwardly with velocity. See, this is a height. We are projecting from a height downward direction. With this direction we are projecting body. So in this type, the body will move like this. See, initially along the motion along the velocity vector, then finally it goes to down to the earth. So what is the case here? Downward projection from a height. Downward projection from a height. This is the fourth type. One more, just copy it, these types. Okay. See, this is x-axis, this will be y-axis. This is the plane. What is that plane? It's inclined plane. This making angle, this plane making angle with the horizontal, that is theta. So we are projecting like this with initial velocity This is one more case. In two-dimensional projection, the motion in two dimension, this is one more type. What is projection up? Projection up in the plane. Projection up in the plane. So this is a plane. We are projecting up. So the body will move in this path. Initially, the velocity vector and the path of the body is just almost in the same direction. After that, it will deviate from that path, from that velocity vector. So last type, projection down the plane, projection up the plane. This is the plane. We are projecting up the plane. We are projecting up the plane. Okay. Last type, projection down the plane. Projection down the plane. See, this is the plane, inclination plane. Projection down the plane. So this is projection down the plane. So if we project it down the plane, the body will move like this. This is sixth type. So these different types of projectile motion only I discussed. I given the graphs. So what I discussed up to now, simply first one is oblique projection. Oblique projection means the velocity vector making an angle theta with x-axis. Then horizontal projection, the velocity vector like this, it is not making any angle with the x-axis, it is parallel to the x-axis. We are projecting like this, horizontal projection. Initially it will be projected like this, oblique projection. This is horizontal projection. One more type is from a height we projected obliquely. From a height we projected obliquely. Oblique projection from a height. Next, this is a height we projected downward projectile. From a height we projected downward projection from a height. One more, we have the two planes. So this is the plane. We are projected up in the plane. Projected up in the plane. We are projected up in the plane. We are projected down in the plane. These two are two more types. So I discussed here 6 types. Tomorrow I want to discuss about oblique projection. Be ready. It is very important topic for intermediate, for IIT JEE, IIT mains, whatever it is. Okay. Thank you. Bye bye. If it is good, you just message me good. That's it. Just copy it and message me if it is good. You just message me it is good. That's it. Okay, bye bye.